Welcome to Ask and Learn.
Alright guys, to solve this problem, we first need to use the given temperature, that is T1 is equal to 15 degrees centigrades, relative humidity, that is phi 1 is equal to 55%, and the pressure, that is P, is equal to 96 kilopascal. So to determine the water vapor pressure, that is PV1, from that dry air pressure PA1, we have PV1 is equal to phi 1 multiplied by PG1 is equal to 0.55 multiplied by 1.7057 is equal to 0.9381 kilopascal. And then we have PA1 is equal to P minus PV1 is equal to 96 kilopascal minus 0.9381 kilopascal is equal to 95.062 kilopascal. So now we can calculate absolute humidity, and from that enthalpy H1. So for the calculation, we will also need Hg1, that is equal to 2528.3 kilojoules per kg, and we have W1 is equal to 0.622 multiplied by PV1 divided by P minus PV1. So we have W1 is equal to 0.622 multiplied by 0.9381 divided by 96 minus 0.9381. So the answer to W1 is equal to 0.00006. So H1 can be calculated through the formula, that is Cp into T1 plus W into Hg1. So we put the values and we get H1 is equal to 1.005 into 15 plus 0.006 into 28.3, and that is equal to 30.24 kilojoules per kg. So next we calculate the specific volume, that is V1, and from that the mass flow rate using the given volume flow rate, that is V1, and V1 is equal to 30 cubic meters per minute. So guys, we have, for V1, small V1, that is equal to RA into T1 divided by PA1, and that is equal to 0.287 multiplied by 288 divided by 95.062, and that is equal to 0.869. So M1 is equal to V1 over small v1 is equal to 30 over 0.869 is equal to 34.52 kgs per minute. So we will also need the same parameters for the exit flow. First, we need to use the given temperature, that is T3 is equal to 25 degrees centigrades, then phi is equal to 45%, and then the pressure, that is P is equal to 96 kilopascal to determine the vapor pressure PV3, and from that the dry air pressure PA3. PV3 is calculated as phi 2 multiplied by Pg2 is equal to 0.45 multiplied by 3.1698, and that is equal to 1.426 kilopascal. Then we have PA3 is equal to P minus PV3, that is 96 minus 1.426 is equal to 94.574 kilopascal. So guys, now we can calculate the absolute humidity, that is W3, and from that enthalpy H3. So for the calculation we will also need Hg3, that is 2546.5 kilojoules per kg, and W3 is equal to 0.622 multiplied by PV3 divided by P minus PV3. So W3 is equal to 0.622 multiplied by 1.426 divided by 96 minus 1.426, and that is equal to 0.009. So H3 is equal to Cp into T3 plus W into Hg3. So we put the values here, it's 1.005 multiplied by 25 plus 0.009 multiplied by 2546.5. So guys, H3 is equal to 48.04 kilojoules per kg. Now let's move on to part A of this question. The absolute humidities at point 1 and 2 are equal because there is no condensation. So W1 is equal to W2. And we also know that the enthalpy does not change from the point 2 to point 3. So H2 is equal to H3. From that, we can determine the temperature T2 and relative humidity phi 2. For the temperature, we will solve the enthalpy equations, that is H2 is equal to Cp into T2 plus W2 multiplied by Hg2. Now we put the values here, is H2 is equal to Cp into T2 plus W2 multiplied by 250.9 plus 1.82 multiplied by T2. Now 48.04 is equal to 1.005 multiplied by T2 plus 0.006 multiplied by 2500.9 plus 1.82 into T2. So T2 is equal to 32.5 degrees centigrades. The relative humidity, that is phi 2, can be calculated. For the calculation we will need the saturation pressure, that is Pg2. Let me write this again in black color. Pg2, that is equal to 4.9 kilopascal. So phi 2 is equal to W2 into P divided by 0.622 plus W2 into Pg2. So now we put the values and we get 0. It's Pg2, so it's 0.006 multiplied by 96 divided by 0.622 plus 0.006, and that is multiplied by 4.9. So guys, the answer to phi 2 is equal to 18.7%. Let me write this here. It's 18.7%. So guys, now we move on to part B of this question. The heat transfer rate Q can now be calculated as Q is equal to M1 into H2 minus H1, and that is equal to 34.52 multiplied by 48.04 minus 30.24, and the answer is Q is equal to 614.46 kilojoules per minute. Kilojoules per minute. So now let's move on to part C of this question. For the conservation of mass, we can calculate the mass flow rate of water, that is MW, through this equation. MW is equal to M1 multiplied by W3 minus W2. Now we put the values. MW is equal to 34.52 multiplied by 0.009 minus 0.006, and the answer, guys, is it's 0.104 kg per minute. So guys, this is the answer to this question. I hope you have easily understood all the calculations and the formulas and all the three parts and their answers. Thank you very much.